Oh, one last day on section 2-2 before I give you a work day. So on question number 39 on 2-2. Okay, so this one it says find the minimum or maximum value of the function and then describe the domain and range of the function and where the function is increasing or decreasing. Okay, so what I want you to understand first off is this. I want to make sure from regular old algebra that you haven't forgotten this. If I was to do this, this right here, does this line have a positive? Is this line going up or is it going down?
Both.
No.
Wait,
Careful. It's actually going up. I tried to mislead you by going like this. Okay? You look at graphs left to right, just like you read. Okay? As you look at it left to right, it's going up. That is a positive slope. Okay? Technically you're right. It is going up and down. You're right. Slope is positive though. The slope is definitely positive, even though it's going down from right to left. As you look, so if I went like this right here, does this have a positive or a negative slope? Negative. Okay, even though I try to mislead you by going from right to left. Okay, so what you need to understand is this graph is increasing all the time. Okay, and because you're viewing graphs from left to right. Okay, I mean sometimes students say, well, how come? What if you read right to left? That's not the way you do it. Okay, I mean if I put the word that there, it's you read it red left to right. Well, if you read it right to left, it's dirt. Okay, well, you don't do that. Well, some of you do. Okay, so you've got to read it left to right on graphs. Okay, now what you need to understand, if I gave you a quadratic, a parabola, as I look at that left to right, is it going up or is it going down? Well, if I start here, it's going down, 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 down. It hits here, and then what? Up, 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 up. Okay? So sometimes it's going up, sometimes it's going down. What you need to understand is this right here is that's our vertex. That's our axis of symmetry. Okay? This is going down, so it's decreasing. And here it's going up, so it's increasing. Okay? So the axis of symmetry is a divide line. On one side of it, it's increasing, and the other side, it's decreasing. Now, be careful. Some students will say, so the left side's always decreasing, the right side's always increasing. Not necessarily. What if I did this? What if I had this parabola? To the left, here it's increasing, and here it's decreasing. Now, some students will say, okay, so can we memorize that if it's opening upward, on the left it's decreasing, on the right it's increasing, and if it's opening down, on the left it's increasing, on the right it's decreasing. If you want to memorize all that, go ahead. I really don't care. Here's what I remember. If the graph's going down, it's decreasing. Graph's going up, I don't care what the graph looks like. It's going up, it's increasing. It's going down, it's decreasing. That's easier for me to remember, okay? All right, so they don't tell you to do this. They just say, describe this graph. Well, I'm going to graph this thing. I'm just going to do a real quick rough graph. Y equals 6x squared plus 1 or minus 1? Minus 1. Okay. Now, this one actually, is this an easier one or a tougher one? Like yesterday we learned some tougher ones. Is this a tougher, easier? Why?
Because it's 1x.
There's only one x, okay? This is one you should have been able to do back in chapter 1. The minus 1 moves it down one spot. The 6, it opens up and it's kind of skinny. It looks sort of like that. Okay, just a really quick rough graph. I can't answer these without making a quick rough graph, okay? Okay, they want to know what the minimum value is. Now, here's where you got to be careful, okay? Right here, this is the low point, okay? And some students say, well, okay, so it's 0, -1, okay? Let me be really clear on this, okay? They want to know what is the minimum value, okay? The minimum value. And what I mean is, let's put this on hold for a second here. Let's say that in January of this year, I measured the high temperature, okay? On January, this represents January. On January 1st, January 2nd, January 3rd, January 4th, January 5th, okay? And we'll say the temperature was, on January 1st, the high temperature was 3 above 0. On January 2nd, it was 1 above 0. January 3rd, it was 4 below 0. January 4th, it was 0. And the high temperature on January 5th was 2 above 0, okay? So, what I want you to understand is, what was the lowest temperature during those 5 days? What was the lowest temperature?
-4.
-4, 4 below, okay? When was the lowest temperature?
3 days.
3 days in January 3rd. So on January 3rd, the lowest temperature was 4 below, okay? So what I want you to understand is on a graph, the x-axis is where it's at, the y value is what it is, okay, what it is, okay? So here, the lowest value is at 0 and it has a value of what? -1, the y value. The lowest it got to, think of it as a temperature scale, okay, like a thermometer, okay? The lowest it ever got to was -1. What was the maximum value? What's the highest this thing ever got to?
It goes on
It goes up forever. There is no maximum value. It goes up forever, okay?
So, the lowest value is always the y.
The value is always the y value. Basically, on any graph, the x is where something happens. The y is what actually happens there. What it is, where and what it is. Okay? Just like where on January, I think it was 3rd, it was 4 below.
Is this like the same thing as the axis of symmetry where you have to put y equals for it?
Like,
you know,
no, they just want to know, no, I don't think so. Let me look here and make sure. No, they just want to know what is the value. I mean, do they even give you a choice of y equals -1? I don't think they give you a choice of y equals -1. No, they don't. If you were to write on a test y equals -1, that's fine, okay?
So why does it matter so much if it's x equals?
Because the x value is not what the lowest value is. The lowest it got to was -1. At
No,
0.
but I mean like in the axis of symmetry, like, remember how you talked about how
Mhm.
important it was to put
Because the
x
axis of symmetry
equals?
is a line. It is a line. If you just say 0, 0 is not a line. 0 is just a number. Okay? It's got to be a line. A line is x equals. Okay? Good question. So -1 goes in the first slot. The domain is, this is from chapter 1, should be all real numbers because it goes left and right forever. Double bar R. And the range, don't look at it left and right. Look at it up and down. It goes up forever. It does not go down forever. It's everything above -1. And be careful. The range is all about the y values. Y is bigger than or equal to -1. Everything above -1. Okay, then it says the function is decreasing to the blank of x equals something. Okay, decreasing. So here's what I'm going to do. I'm going to draw my axis of symmetry. Right here, through the line x equals 0. Okay, x equals 0. So, I think it's easier if I do this. What's happening here on this side? Is it going up or going down?
Decreasing.
It's decreasing, and here it's increasing, okay? And they ask us, it says, the function is decreasing to the blank of what? To the left of the axis of symmetry, x equals 0. Do you have to type in x equals or not? No, you don't need to type in x equals. So therefore, it must be increasing to the right of x equals 0. Okay? Just talking about where the graph's going up and where the graph's going down.
So we always start on the left side.
Doesn't matter. Well, we did. I would label them and then just check. Because the first thing it said it was decreasing, then it said it was increasing. Just make sure you read it carefully.
Because we could, if you start on the right side, you decrease.
No. If I start right here, if I want to look at this side, this is the divide line. I still have to look at it left to right. I would start on the left. I would just say I'd always start on the
But
left.
then if you started on that side, then
Which-
if you went from
Here?
No, other side.
Here?
And you started down
Down here?
and went left to right, it'd be.
Left to right? Left to right?
Right to left.
Okay, yeah.
Okay, this is left.
Yep.
This is right.
You gotta do what Carlos Orton does on the
Want me to put on your shoes too, so you don't screw those up? Oh yeah, that's how I had to do it, man. Come on, I had to sit. I tried not to make fun too much, but, oh yeah. We're all good? Makes you feel better. The second person I wrote left and right on the board for this week. The other one's Nathaniel Maurer. I don't know if that's good or bad for you. Okay. All right, 41. Okay, so we have y equals -x squared minus 4x. It's 4x minus 2. Easy one or tougher one?
Actually, easier one now.
It has double.
What's the vertex?
Exactly.
Okay. So is it easier or tougher than you said? Easier than it was yesterday, because we've done, but it's a little tougher, because I don't know the vertex yet. What's that little formula, you guys remember?
B over
Close.
2A.
Not B over 2A. Negative B over 2A. Negative B. Okay, and what's A?
One.
Careful.
Negative one.
-1. What's B? -4. What's C?
Delete it.
Who cares? Okay. So, again, be careful here. I think I said this yesterday once. I'm going to say it again. I really shouldn't be saying negative B. I mean, it's not wrong, but I think it'd be better to say the opposite of B. The opposite of B, okay? Because some students think, well, there's got to be negative on top. No. B is -4, so it'd be -4, which is 4, over 2 times -1, which is 4 over -2, which is -2.
We also have a negative times a negative. Oh, no, it's not negative.
Negative plus a negative is a negative.
Excuse this interruption. Freshmen with the last name E through H, please report to the field house for vision testing at this time.
Okay. And let's find the y value. So let's plug that in. And I'm going to do this real slow here. Plug it in for every x, and when you plug it in, put it in parentheses. Okay, so I see a negative. Now I see an x. So I'm going to put, what's the very next thing I'm going to put on the board? No, a parenthesis. Parenthesis, -2 squared. -4. Oh, there's an x. -2. Take away 2. What calculating did I just do?
You just replace the X.
So what calculating did I just do? What computation did I just do?
Substitute.
So what computation did I do?
I don't know.
What? I thought you were going to say it. Come on, somebody say it. You're right, I plugged stuff in. So what calculating did I just do? None. I didn't do any. I just plugged them in. I just plugged in -2. Now I'm going to do some computation, okay? Be careful here. Some students will go, -2 is +2. And you're not wrong, but think of it as subtraction. Do you subtract first or do powers first?
Powers.
And it makes a difference. If you made -2, 2 squared is 4. You're supposed to, -2 squared is,
Negative.
well, 4, but that makes it -4. That's tricky. You're squaring -2. -2 times -2, which is +4. Then put a negative sign in front of it. -4 times -2 is +8. Take away 2. A -4 and a +8 is 4. Take away 2 is 2. So the vertex is -2, 2. So back 2, up 2, put a dot. I just want a rough graph here. Is this parabola opening up or is it opening down?
Down.
Why? True or false? It's opening down because all 3 of these are negative.
And then false.
All 3 of them are negative, but they don't all have to be negative to make it go down.
Just the first.
Just the first one. Okay, if it was negative, positive, positive, it still opens down. So a real quick rough graph looks like that. Okay. The maximum value. What is the maximum value?
2.
2. At what? At where at? Where was it 2?
Doesn't matter.
Well, no. Where was the actual value of 2 at? On what date? January. It's kind of weird saying this. January what?
-2.
January -2nd, which is December 29th. But we're not going to do that. Okay. So the maximum value is 2. What's the minimum value? What's the lowest this thing gets to?
Infinity.
You're close, but totally wrong. Not infinity. Not infinity. Not positive infinity.
Negative.
Negative infinity.
I
So
thought you wouldn't.
it goes down forever. Okay. All right. Number 2. Was not number 2. It was maximum was 2. Domain is all real numbers still. It goes left and right forever. And the range. It's everything below 2. Everything below 2. So y is less than or equal to 2. Okay. What's that?
No.
And let's do this. Let's draw our axis of symmetry right here. What's happening on this side of the axis of symmetry?
It's going up.
It's going up, so it's increasing. Over here, it's got to be decreasing. Okay? And if you didn't already, I think you guys know this, every parabola, one side's got to increase, the other side's got to decrease, okay? All right, so what are they asking here? says the function, they start off with, make sure you read it carefully. Last one started out with decreasing. This time it's saying it's starting off with increasing. The function is increasing to the blank of something. It's increasing to the left of x equals -2. You don't need to type in x equals. And it's decreasing to the right of x equals -2. What's happening at -2? Is it increasing or decreasing?
No.
Neither one. It's like when you throw a ball up in the air, straight up in the air. Initially, it's going away from you. It goes away, away, unless you got a heck of an arm, and eventually it comes back down towards you. But for just a blink of an eye, it just hangs there. It's not going anywhere, and then it comes right, it reverses course. Okay? 43. Still one more thing we need to talk about.
You had a track that was like straight up, and it was just hanging out in
I was
midair, and
gonna
then
say
air.
negative one, parentheses negative two.
What's that?
Because last one we just did, the,
Like, he just
negative,
sits there chewing.
parentheses
What if I
negative
threw a
two
shot
squared,
over there?
negative one.
Mhm.
I was gonna say negative one, parentheses negative two, would that still work?
Where at?
Right there, right now.
Yep. And
Would
what you,
that work if I put a one there, negative one,
for this?
for the negative in front?
Oh, a -1 times it? Yeah, that's fine.
That's what I was gonna say,
Yeah.
like, you know.
Same thing. Yep.
Okay.
Okay, so number 43. Okay, so we have -287. -287. Y equals -2x squared. That's a -8. 8, 7. 8x 7. It's 8x plus 7. Okay, so -2x squared plus 8x plus 7. This is a tougher one because we have two x's. I have no idea what the vertex is. So we need that little formula again. -b over 2a. A in this case is -2. B is +8. C we don't care about. Okay? So, -b, or the opposite of b, is -8 over 2 times a is -2. -8 over 2 times -2 is -4. -8 divided by -4 is a +2. So, the x value of our vertex is 2. In order to find the y value, plug it in for all the x's and make sure you put them in parentheses. So we have -2, 2 squared, plus 8 times 2, plus 7. Make sure we do powers before we times. 2 squared is 4, times -2 is -8. 8 times 2 is 16, plus 7. A -8 and a +16 is 8, plus 7 is 15.
Big math.
Yep. Okay, so let's do a very quick rough graph here. Again, the question was brought up yesterday. How do you know when he wants a quick rough graph, and how do you know when he wants a really nice graph? On your test, I'll tell you. I'll say, graph this, plot 5 points. Okay? So for this, they didn't even tell us to graph this one. So a rough graph is sufficient. Okay? I mean, we're only doing the graph. They didn't tell us to, but I have a hard time answering this question without a graph. So we have 215. Here's 2, here's 15. And this thing opens what? Negative, so it opens down. So there's a quick rough graph. And what are they asking us? What is the maximum value? Well, the maximum value is 15. The highest this ever got to was 15. Okay? And domain is all real numbers. So it goes left and right forever. But the range, look at it up and down. It does go down forever, but it doesn't go up forever. The highest it ever gets to is 15. So it's everything under 15. Y is less than or equal to 15. It's everything at 15 or below. And then they want increasing and decreasing. So on this side, it's increasing because the graph's going up. This side, it's decreasing. And they ask increasing first? Is that what they asked? Increasing to the left of the axis of symmetry, which is x equals 2. And it's decreasing to the right of x equals 2. Hopefully it feels like we keep doing the same problem because we basically are. And then we got one more thing to talk about after we do one more like this. We got 53, 55, 57, and 59. Okay, yeah, we got 4 more to go through. We got one more like this, and then one more concept to talk about. So 45. 45. Okay, we have 2x squared minus 12x equals 2x squared minus 12x. Be careful on this one. Just hold strong to what you've been saying the last 2 days. Easier one or a tougher one, would you say?
Tough.
Why? I agree. Why?
2x.
2x's. Now some students go, but there's only 2 things here. There's nothing over here. Sure there is. What would C be? We don't care what C is, but what would C be? 0. Okay? But it's still tougher because there's still 2 x's. So we still need negative b over 2a. A is 2. B is negative 12. Watch your negatives. Okay. So let's find our vertex. The opposite of b is positive 12 over 2 times a is 2. I don't think anybody's asked this yet, okay? I just want to make sure if anybody is thinking this. Occasionally, almost every year, students say, where'd that 2 come from? It's part of the formula. It's always there. It's b over 2a. It's always there, okay? At some point this year, I'll explain where this formula came from. Don't worry about it right now, though. Just believe it. 12 over 4, which is 3. Okay, so the x value of the vertex is 3. Question?
Oh,
You good?
yeah, I
Okay.
just said, I put
A and B in the switch. Don't do that. I had somebody do that yesterday. Okay? I won't say who did that summer. Okay. Okay.
You're funny.
I kind of, he laughed. Somebody laughed. So, but there. Yeah. Okay. So we got to find out what our y value is. So we got to plug in 3. So we have 2 times 3 squared minus 12 times 3. All right, make sure we do our powers first. 3 squared is 9 times 2 is 18. Minus 12 times 3 is 36. And be careful here. Some students will get in a big hurry and go, oh, 18 minus 36, that's 18. No, it's not. It's negative 18. Okay, so our vertex is 3, negative 18. Make sure we haven't forgotten this. What's our axis of symmetry? 3? X equals 3. Okay. Oh, I went the wrong way. Let's put it, we gotta go down 18, let's put that way up here. So 3, negative 18, put a dot. I want to slow down on this because I just want to make sure there's still, every year there's at least 1 or 2 students, I don't want to embarrass anybody here, but I mean, they wonder, how do you know if it opens up or opens down? Which is it? Does this open up or does this open down, this parabola? Up, why?
There's no negative under 2x.
That's positive. All you got to look at is that right. Before I even graphed, I knew this thing was opening up. Okay? So it looks sort of like that. And there's our axis of symmetry. Okay, so the minimum value is down here at negative 18. That's the lowest it ever got to, was negative 18. Domain is all real numbers, left and right forever. Range, don't look at it left and right, look at it up and down. It goes up forever. It doesn't go, it only goes as low as negative 18 though, so y has to be everything above negative 18. And then we don't know if it's increasing or decreasing. On this side of it, it's decreasing, it's going down. And again, and I'm not making fun of Garrett here, okay? I already made fun of him once. I'm being serious, because there's more than one person that would think this. Some students will go, but it's going up, Mr. KO, it's going up. But you're going right to, but you've got to look at.
left when you try that.
Right, but it's if you go right to left, you get the exact opposite answer is what you're supposed to get, okay? Just like red is dir, it's totally backwards, okay? If you look at, if you go right to left, it's going up, but you're supposed to look at it left to right, so it's going down. This one's going up, so it's increasing. What do they ask first? Decreasing first. It's decreasing to the left of 3, x equals 3. And it's increasing to the right of x equals 3. And you don't need to type in the x equals, because they're already there for you. Okay, 3, 5, 7. Okay, we may only do 3 of these instead of all. I may do one of them on. Yeah, we have to go as far as 60. We'll probably do 3 of these, and then I'll do one of them with you guys on Thursday. Thursday's definitely a work day. Okay. All right, so let's look at 53. Okay, 53. Next one on the assignment. We have not talked about this. It says, all right, y equals x plus 3, x minus 3. Do you know the vertex?
Nope.
You shouldn't. You might be going, well, you might be thinking it's in vertex form because you see parentheses there. But it's not in vertex form because what else do you see?
Boundary lines.
2.
2 x's. There's 2 x's. You don't know the vertex right now, okay? But I will tell you this, okay? What I want you to understand is this, okay? This graph touches the x-axis in 2 spots. It touches at -3 and at +3. This is a really bad example to start off with, okay? We're going to go ahead and do that and then just stop for a second. If I gave you this, this touches the x-axis in 2 spots at +5 and -7. How can I tell just by looking at the equation that it touches the x-axis at -7? And this, I'm looking for one word. One word. How the heck did I know it's going to touch whatever this looks like, this parabola is going to go through -7 and +5. Yes, sir?
Opposite.
Opposites. Opposite of this, opposite of this. Why is this a bad example? Some students might say, I see a 3 right here, so it touches at 3. I see a -3 here, it touches -3. That's not the way you do it. What'd you say? You said the same thing, Garrett? Is that what you said? The same? Is that the word you said?
Opposite.
Opposite. What's the opposite of +3? -3. What's the opposite of +3? 3. Okay, it touches at those 2 spots. Okay, now, does this parabola open up or does it open down? Why? There's no negative out front here. It's going to open up. So a really quick rough graph is going to go like this. Okay? Now that looks really bad. Okay? And I'll tell you this. The vertex is going to be at 0 something. That's a really bad drawing I did there. Okay? It's 0 something. Okay? Now, I didn't tell you how. Okay? Now you said, well, if I draw a really pretty graph, doesn't matter. Whether it's pretty or ugly, it's going to go through 0. This one, the vertex is not going to go through 0 something. It's going to go through -1 something. -1 something. Any idea why? How do I know it's going to go through -1 something?
She's lopsided.
I'm a bad drawer. Okay, that's a bad drawer back here. Any idea how I know it's going to go through -1 something?
Wait, it still goes through 0.
Well, okay, the vertex is not 0 though.
Oh.
You're right, it goes through 0 something, but it doesn't go. That's not the vertex. The vertex is -1 something. I'll give you one more. If I gave you y equals x plus 1, x plus 7, where does that touch the x-axis? At -1 and -7. This one has a vertex at -4.
Oh,
Why?
it splits it in the middle.
Smack dab in the middle. Now, so I was hoping somebody would say, because it's in between them. Not just between. Between's not good enough. Not just between them, okay? It's got to be smack dab in the middle, okay? Is Hope is Hope between you and me?
Yep.
Here. Yeah, she's smack dab in the middle?
No.
Is that better?
Yep.
Closer? Okay. All right. So it's smack dab in the middle, okay? So how do I know it goes through 0? Because 0 is 3 away from 3 and 3 away from -3. So the vertex, what do they want? They want the vertex, the x-intercepts, the vertex, and axis of symmetry. Okay. So we know that the vertex is 0 something. And it's 0 negative something. 0 negative something. Let's go back. We've talked about this for 2 or 3 days. How do we find the y value?
Plug in.
Plug in what? Plug in what for x?
0.
For what x?
All.
All of them. If I plug in 0 here, we have 0 plus 3 times 0 minus 3, which is 3 times -3, which is -9. Does it make sense that it was -9 instead of +9?
Yeah.
Yeah, it couldn't have been +9, because it would have been where? Up here, which means the parabola would have opened down, and it doesn't. It opens up.
It just came.
Okay, so we know what the graph is. The x-intercepts. How do they want you to plot them? How do they want you to say the x-intercepts? The x-intercepts. Oh, they just want you to say 3 and -3. Okay. So we got the x-intercepts, the vertex, and the axis of symmetry. AOS is what?
X equals
X
0.
X equals 0. Okay. So I said a few minutes ago, there's one more thing we had to learn. This is what it is. If I give you the x-intercepts, mean where it touches the x-axis. That's what it means by the x-intercepts, okay? Where do we find, if I give you the x-intercepts, where do we find the vertex? Smack dab in the middle. Okay? Let's do 2 more. It's 55. All right, so what do we have here? 3, x plus 2, x plus 6. X 3, x plus 2, x plus 6. Okay? So, where does this touch the x-axis? Think of what Garrett said.
-2.
-2,
-6.
-6. How'd you do that in one word?
Opposite.
Opposites. Okay?
Wait a minute.
So we're at -2. That looks really bad. 1, 2, 3, 4, 5, 6. We're at -2 and at -6. Okay? Tell you what, if this 3 was a 13, would the x-intercepts change?
No.
No. Would the graph change?
Yeah.
Yes, it would. 3 makes it skinny. 13 makes it what?
Extraordinary.
Very skinny. Very, very skinny. Okay? All right, so where is the vertex? What's the x value of the vertex? Which is where?
3.5.
-4. -4 something. Okay, is this opening up or is this thing opening down?
It's gonna open up.
+3, it opens up. That looks really bad. Vertex is -4 something. Because -4, it's not just between them, it's right in the middle. Right in the middle. And I tell you what, just want to make sure, shortcut here. How do you find the middle of 2 numbers? And then some students say, well, you just work your way in, in until you get to the middle. Okay, you could do that. So if I gave you the numbers like 1 and 7, you could go 2 and 6, and you could go 3 and 5, and then 4. No problem with that. What if I give you the numbers 23 and 898,246? You want to work your way in like that? You don't want to do that. Anybody know how you find the middle of 2 numbers? It's a 2-step process. For example, and some of you can do it in your head, you don't even realize it. If I give you the numbers 2 and 10, what's in the middle of 2 and 10? Right in the middle of 2 and 10. Close, not 5. 6. How do you get the number 6? Using the numbers 2 and 10. You got to do 2
Person with
steps.
the last name J through N,
Add them together
please
and then
report
divide
to the field house
Bye.
for vision testing.
By what?
by 2.
Exactly. To find the middle of 2 numbers, you add them up, divide by 2. So if I gave you 48 and 38 million, whatever I said, just add them up, divide by 2, there's the middle. Okay? So
Where's that? Run.
So it's -4 something. How are we going to find the y value? Substitute for both x's. So we have 3 times -4 plus 2, -4 plus 6. So 3 times -4 plus 2 is -2. -4 plus 6 is +2. 3 times -2 is -6. -6 times 2 is -12. Okay, we got the x-intercepts, we got the vertex, and the axis of symmetry. Axis of symmetry is x is negative 4. Vertex, axis of symmetry, we got the graph.
Would you multiply the parentheses first?
What's that?
Would you multiply?
Like these first?
Yeah.
That's a good question. Short answer is it doesn't matter, okay? Because you think you do parentheses first, like parentheses, exponents, multiply, divide, add, subtract. When they say parentheses, they mean do inside the parentheses first, okay? And what does it mean when you have parentheses next to parentheses? Multiplying. It doesn't matter where you multiply it. Okay, last one for today, 57. They'll only give us one to do together on Thursday, and then we'll have a whole work hour. 57, what do we got here? Okay, the graph, and then actually the same old stuff. Negative x equals 6. Okay, listen carefully because I've been saying something, but I want to explain why this works, okay? The reason why the opposites work, when you plug in opposites, you get what? When I plug in negative 3, what do we get? What do you get when you add opposites? 0. When I plug in, what's 0 times garbage? 0. Okay? So when you plug in the opposites, it's what makes 0. It's what makes 0, okay? Now, there's going to be two x-intercepts here because we have two x's, okay? This one, students have no problem with, okay? It's going to touch at negative 6. Now, again, I just said this a second ago. Listen carefully. What is so special about negative 6? When I plug in negative 6, this turns to what? 0. It turns to 0. This next thing is so easy that students struggle with it, okay?
This is 1.
I plug in negative 6, this turns into 0. What can I plug in for this to make it 0? Tell you what. No, be quiet.
I'm so confused.
Hang on a second. Some of you said, okay. If I give you this, right here, we have a test in a few weeks. What's your score going to be? Hopefully really good, but what's your score going to be?
85.
You know that?
No.
What's it going to be?
100.
I know it's not going to be that, okay? Who knows what their test score is going to be?
No one.
Nobody does. So we'll say it's X%. Well, what do I need to do to make that a big fat 0? Plug in, not 1, 0. Again, what is those? Don't get away from opposites. I probably shouldn't have said that. What's so special about it is this turns into 0. Negative 6 plus 6. What makes x 0? 0 makes x 0. So it touches at 0 and negative 6. Now if you're going, well, how do I graph that? Very simply. Here's negative 6. Where's 0 at?
Right in the middle.
Right there. Does this open up or does it open down? Negative opens down. All right? So where is our vertex at?
-3.
How come?
Because that's in between.
Gotta do better than that. Not just between.
Smack dab.
Smack dab in the middle. You don't need to say smack dab.
So
but-
I'm confused.
Yes, sir.
So what do you mean we plug in the just for the positive 6 we make it just the negative 6, right?
What we're saying is this.
Because you're saying
You said opposites, and I said good job, and you were right. Here's what I probably should have said. What turns this into 0? Tell you what, if I give you this right here, no calculator. 2 times 5 times 7 times 8 times 9 times 3 times, do you know this yet?
no.
Me neither. Times 5 times 6 times 0 times 4 times 8 times 7.
Yeah.
I'm not done. You still want to stay with 0?
Yeah.
Very good. Why?
Because if you times
As soon as I put that 0 in, it all goes away. Would you use a calculator on that? I hope not. Now, if I took the 0 away, then you want to use a calculator, okay? As soon as I plug in a 0, it all goes away. When I plug in negative 3, this is 0. What's 0 times garbage? 0. Plug in 3 here. What's 3 minus 3? 0. What's 0 times other garbage? Still 0. It makes 0. What makes this 0? Negative 6. What makes this 0? Because we're not adding or subtracting anything off to that.
So we want to make everything 0.
Everything's 0, okay? All right, how are we going to find out the y value? Plug in negative 3 for both these x's. Negative 3 is 3 times negative 3 plus 6 is 3. So negative 3 9. So we have everything, the x-intercepts, the vertex, and the axis of symmetry. The axis of symmetry is x equals -3. Last thing, before I let you guys click on these if you even have time. I want to be very clear on this guy. I have a feeling there's more than one person, not just Garrett, that's a little bit shaky on this right here. If I give you this right here, y equals x minus 9, x plus 4. What makes 0?
0.
No, not 0 on this one.
Oh, negative, or positive
9
and
and -4. What if I had an x there?
0.
0. What if I had a 5x here? Still 0. Because it's saying 5 times what gives you 0? 0. What if it was 15x?
Same thing.
Still 0. It's what makes 0. Okay? We'll talk about more on Thursday. Okay, you got a couple minutes. You might be able to click on these.